Alright, so now we're down to rationalize the denominator for the tough ones, the big boys basically. The ones where you've got a number, add a third, yeah, or take away a third. And it could be, I could have put like a number in front of here as well, but it's basically something add, like a number add a certain amount of thirds. Now, this one is considered difficult. Yeah, this is considered very, very difficult. But I want you to kind of think, look, it's still a rationalize the denominator question. So first let's understand why this is a problem. So, first thing, the question will say, write in this kind of form. It doesn't matter how the question's saying. They might say rationalize the denominator for this. It might say write in this kind of form. But basically, if you see a fraction where on the bottom you've got something add, a certain amount of thirds, yeah, over here it's just one of them, you are doing the rationalize the denominator question, right? If you ever see a fraction with a third on the bottom, you're doing a rationalize the denominator question. It doesn't really matter how they kind of word it or something, alright? So just get that in your head, basically. So the method's always going to be the same. But anyway, so yeah, now it should be clear that it's a rationalize the denominator question. And look, again, here's the problem. Rationalize the denominator. Right now we have this thing. The denominator has a third in. Therefore, the denominator is not rational. Okay? Because of this silly little third here. So, it's a simple thing. So again, like just how we did on the easier rationalize denominator question, we're not going to change this number. Just also, by the way, let's stick this in the calculator. Let's do 3 divided by 2 plus root 5. And that, the actual value of this thing is like, let me change the color. It's like 0.7082, so on, yeah? So we're not going to change this. So again, we're going to be timesing it by 1. It's the only number we can times by 1. But again, we're going to use, a certain version of 1 where it's like this fraction. So you've got this top over this bottom. And obviously they're going to be the same, so, because it has to equal times 1. So the question is really, look, what can we multiply 2 plus root 5 by, all of that by the way, by, so that over here we get like a number, so it pops out to 14, 20, we don't really care what the number is, but it's a number, there's no thirds left. And you actually have to use, so let me first go through some of the mistakes people make. So one of the mistakes people make, because do you remember in the last question, you get like 6 over root 7 or whatever, yeah? And you just ended up in a way, a lot of people just think, oh, it's times top and bottom by whatever's the same on the bottom. But some people might just, that's the next mistake we're going to go to. But right now, do you remember how I even told you, even if you had this, yeah, you just times by the third. Well, alright, here's the reason why that doesn't work. So imagine we were trying to do that. So here's the deal. Again, you don't really care what happens on the top. I mean, it's just going to be 3 root 5 anyway, but you don't care. The important thing is that the bottom ends up being rationalized. And you'll see in this instance it doesn't, because look, the bottom, the first one, is 2 plus root 5. And you times this by root 5, which would just be written like this. So it's a single bracket multiplication. So look at this. So when we do that, we get 2 root 5 plus 5. Root 5 times root 5. So it's great. So we kind of like rationalize that bit. But obviously we had to multiply also this 2. So that makes it 2 root 5 plus 5. So that's not worked, because we still got a third. So don't do that. So that's a common mistake. When you get a question like this, you just go ahead and think, all right, well, there's a root 5 here, so I multiply top and bottom by root 5, because that's what I did in the last question. And this is why this question is difficult, because more or less everyone who does this question doesn't really understand why they're doing it, what the question is asking. That's a mistake. So another thing they might think, they're like, oh, in the last question, if we had something like this, root 7, well, maybe it's because I just times top and bottom by whatever was here. So really what I'm going to do here is I'm going to times top and bottom by exactly the same thing. Yeah, the answer is, well, again, you can check. So right, so now what we're doing is 2 plus root 5 times 2 plus root 5. Well, let's do the multiplication of that. So listen, double bracket, so we're just going to do that. So that gives you 4. It's a good start. Now look, that gives you plus 2 root 5. Okay, worrying, but it might not be the end. We're not done yet. That one also gives you a positive 2 root 5. Yeah? And finally, root 5 and root 5 gives you a 5. So let's kind of simplify that. So obviously these two join together. That's going to give you 9. And these two join together. That gives you 4 root 5. Notice how this works exactly the same as this would. Yeah, that would simplify to that. Yeah, so if we did that, we get 9 plus 4 root 5. Right, so again, that's not helped us either, has it? We've still got that root 5 on the bottom. So that's why I kind of say that's the second common mistake. And it always comes from the same thing. Some, you know, you don't really know what you're doing. You're just trying to follow these rules. Well, okay, so if you do want to follow a rule here, you can just take this rule. Because it works every single time. Basically, you times top and bottom by exactly what's on the bottom, but with a negative. So I'm saying this is what you're going to multiply it by. Exactly the same, but with a negative. And you'll see why. Again, the top we don't care about. We're bothered about this. Now, here's why it works. So if we do it this way, look, so we get 2 times 2 again. Again, they're both positive as well, so I'm going to make it clear with this as well. Yep, so that gives you a 4. Now this one is a plus 2 times a minus root 5. So that's going to give us minus 2 root 5. But watch this one. This one is a plus 5 times a plus 2. So that gives us positive 2 root 5. And finally, be careful here. This is root 5 times minus root 5. So that's going to give us minus 5. Does that make sense? Positive and minus 5. A lot of people make the mistake. They'll even do this bit right, but then they'll do the positive here. That's not right. So now let's look at this. Either you get this, because do you see, this is very similar to 4 minus 2x plus 2x minus 5. Can you see that minus 2x is going to cancel with this plus 2x? So you end up getting 4 minus 5, which gives you minus 1. And that's exactly what happens here. So look, this bit, don't forget this is really a plus. Yeah, that cancels with that. And that's what happens every single time, as you'll see with different questions. Then you're just left with 4 minus 5. So the bottom becomes minus 1. It becomes minus 1. Now the top is simple. We're just doing 3 times 2 minus root 5, but we never really care about that. We just have to do it to get the final question, get the final mark. This one finally becomes minus 3 root 5. See? So this one becomes 6. It's 3 root 5. Now, so that's really the top, that's the rationalized denominator bit done. Obviously now you have to just kind of simplify wherever you can simplify. And hopefully you guys should know that you never leave a negative on the bottom of a fraction. It's just considered like bad practice. So what you do with that one is you times the top and bottom by a minus 1. Because hopefully you can see straight away minus 1 times minus 1 will give you 1 on the bottom. So you just, minus 1, the top becomes this. It's just going to reverse the signs basically. So you get minus 6, you get plus 3 root 5. Which you can write exactly like that. You can just write like this. Yeah, obviously anything divided by 1, you can just get rid of that. And that's our answer. 3 root 5 minus 6. So here you go. Your A was, well, it's actually this, isn't it? You can look at it as minus. Yeah, your A was actually minus 6. And your B was 3. So that's what the answer to this question was. But do you see the logical steps again? You understand what we're doing. So they give you this thing. They ask you to rationalize the denominator, or they tell you to write in this form. It doesn't matter. If you see a fraction with a third on the bottom, you've got to rationalize the denominator. So we're trying to rationalize the denominator here. The denominator right here has a third. That's why it is irrational. So we times top and bottom, and we're not using a rule. We're not timesing it by the bottom third. We're not timesing by, whatever the same thing on the bottom. The only reason we're timesing top and bottom by this, yeah, no rule, it just happens to be the one where if I multiply these things together, I get a whole number. That's all I care about. And then I just do the top like that. That's it. So hopefully, look, there's a few things to this which make it kind of difficult, I guess, in theory. The first thing is people screw up the kind of, what to multiply top and bottom by, because they're following rules and they assume the easier rationalize the denominator was going to work exactly the same as this. It didn't, but here's the thing. So that's really the first hardest step. You'll see here as well, I said method, multiply top and bottom by the third, I shouldn't say the third, but by whatever, makes the denominator a whole number. And it just happens to be, whatever that is, minus. Yeah? Instead of the plus, you make it a minus. If this was a negative, you would have made this a plus. That's why I say same as the denominator with the opposite sign. Every single time you have that thing cancel. Every single time without fail. And that's it. And if you get a negative on the bottom, make sure you clean it up. And that's really all there is to this question. So let's have a look at maybe one or two more. By the way, these questions, for some reason, they don't generally tend to say rationalize the denominator. But take my word for it, if you see it, you are going to rationalize the denominator. So let's have a look at this one. This one shows you 1 plus root 7 over 3 minus, oops, that wasn't too great, 3 minus root 7. So here's what we're going to do. We're going to times top and bottom by 3 plus root 7. You see? So exactly the same as this, but with the opposite sign. So again, the top we don't really care about, but let's focus on the bottom. Okay, so positive 3 times positive 3 gives you 9. Notice this as well. This one will always give you, say it gives you plus root 7. The reason this always works, because that minus always gives you the opposite. So that's why these cancel, that's why it's worked. So you can write it, but in a way they're cancelled. And then finally, minus root 7 times plus root 7 is a minus 7. So you can see the bottom, it just ends up becoming 2, which is nice. The top one, you got plus 1 root 7, 3 plus root 7. Just take your time here. So you got 3, got plus root 7, got plus 3 root 7, and plus root 7 times root 7, which is 7. So that becomes, if you simplify this, 10 plus 4 root 7. Now, by the way, I should have actually wrote this initially. It says it wants you to write this in the form a plus b root 7. Obviously, we don't have that there just yet. But what you can do here, again, we're going to look for any common factors. And if it's telling you to write it like that, where a and b are integers as well. Integers, remember, just means whole numbers. And this is what you do. Can you see the top can factorize to give me this? Yeah, so that literally means that I have written the top and bottom as a chain of things multiplying. Factorizing, by the way, is how you make stuff where you've got a few different things, a few terms. If you've got loads of terms and you can factorize it, you've essentially made it into a chain of things multiplying. Cancel that, and you're left with 5 plus 2 root 7 over 1, which we don't have to bother with that over 1. That's it. Yeah. A is 5, B is 2. I guess I can do one more. But it's really, to be honest, look, it's pretty simple. Just multiply top and bottom by whatever the denominator is, but make sure you reverse the sign. That will mean that the thirds end up cancelling themselves out. And that's it. Obviously, don't care about the top because it's a rationalize the denominator. It doesn't have any care for whatever's on the bottom. I guess, what can I was going to show you? Yeah, I guess I'll show you an example like this. I'll point out why I'm showing you this. Okay, the only reason I'm showing you this is because, say you've got 3 times root 2, does that change anything? No, man, just kind of times top and bottom. by the exact same. That's all you have to remember, this exact same. Watch how it goes. And here, I'll show you y as well. You can kind of see it straight away. So let's look at what the bottom becomes. Alright, so this one is always just going to give you whatever that is. So that's going to be 16. Now this one, notice this one gives you plus 12 root 2. And notice how this one gives you minus 12 root 2. Every single time they cancel. When you make the brackets exactly the same but you change the sign, every single time it cancels. Yeah, and then finally you just got to do that times that, which you've got to be careful. So it's positive times the negative, which is going to be negative, and you just got to do 3 root 2 times 3 root 2, so 3 times 3 equals 9, 2 times 2 equals 2, 18, alright? So that ends up giving you 16 minus 18, which is minus 2. Alright, and then I guess the top can be sometimes just be a little bit of a headache. All you got to do with that is, you know, it's going to come out ugly. Don't worry if the top comes out ugly. Your top, you couldn't care less about. Just take your time with it and you'll be fine. 24. This one is going to be 18 root 2. This one is going to be 8 root 3. And this one, just be careful, 2 root 3 times 3 root 2, 2 times 3 is 6, root 3 times root 2 is root 6. Can't do much more with that, unfortunately. And that's it, you know, that's literally it. You might notice here that all of these numbers on top go into 2, so you can rewrite the top as, you know, you can factorize it with 2 out. Obviously you're going to try and cancel it with that. You didn't see that. Again, I mean, like, don't stress this too much. Like, you know, even if you get here, you got most of the marks, kind of thing. Yeah, obviously this is just, we can write this as 2 times minus 1, so we can cancel that and that. Which gives you 12 plus 9 root 2 plus 4 root 3 plus 3 root 6. Obviously now that's still over minus 1. But we don't like minuses on the bottom, so we times top and bottom by minus 1. And all that's going to do is just literally, you know, all of that. So the whole top's going to become a negative, minus 12, minus 9 root 2, and that's just left like this. Okay, minus 4 root 3, minus 3 root 6. Now it's all over 1, which we don't need to write. That's our answer. Yeah? Same steps, step by step. I guess really where your practice has to come in is just make sure you get comfy multiplying brackets with surds. And with that one, all that is understand how similar it works to algebra, and just take your time, break these things down. Yeah, and just practice is all you need with this. So okay, so that literally is all I have to say on this. There's not really much more I need to add. Yeah, and I think the next video, I'll just wrap it up. I'll do one more video with surds, because there's one very important thing I need you to know about surds, and it's really more about square roots. But then I'm just going to go through loads of questions, alright? That's it for you. So loads and loads of exam questions as they come up in the papers. But yeah, everything here on these videos is surds, every little last detail you need to know. Every little last detail. Watch this a few times if you don't get it. If you find it tough, the one thing you've got to do, yeah, is whilst I'm doing it, I want you to pause the videos, try the questions yourself. With a pen and paper, right? You've got to get things. I don't want you to see it and say, okay, yeah, cool, I get this, I understand. Get your hands dirty. You can't watch maths. You've got to kind of do maths. So yeah, I mean, look, if you're still struggling and you just sat there looking at the screen, not doing much, then you know what? I've got very little sympathy for you. Literally just grab a pen and try this. You might surprise yourself. Yeah, cool. All right, I'll see you in the next video.